Chapter 8, Section 6. So what we're doing is kind of an extension of the previous section. We are going to be factoring again, but instead of factoring a polynomial that's in the form of x squared plus bx plus c, we will be factoring a polynomial that's in the form of ax squared plus bx plus c. So the difference is we have this little added extra coefficient. And so basically what we're saying is now there will be a number other than 1 in front of the x. Okay? When that happens, there's a lot of stuff that's similar and a lot of things that are different. The different thing is that instead of just looking at c and finding our factors of c, we have to find factors of a times c. Okay, so a times c equals 10. And actually, let me write it like this. A times c is 5, right there, times 2, right there, which is 10. So we want, so now comes the part that's similar. We find factors of 10, and we make a little chart. And we're going to end up finding the sum. So factors of 10 are 1 and 10, 2 and 5, negative 1 and negative 10, and negative 2 and negative 5. Now at some point, you'll learn that we really didn't even have to do these because this isn't negative, so there's no way that we would use these. But for now, you can always just, find them all. And then the sum, 1 and 10 is 11, 2 and 5 is 7, negative 1 and negative 10 is negative 11, negative 2 and negative 5 is negative 7. And what we're still looking for is which one gives us plus 11. And so that's that right there. So we're looking at numbers 1 and 10. All right, so now here comes the different part. So we're going to take this polynomial and rewrite it. And instead of writing 11x, we're going to write it as 1x plus 10x. Okay, so what happened is, instead of 11x, we wrote it like this, which is still 11x. It's just in a different form. And then we still write plus 2. Okay? Next step is to separate these two. Make that right there a little binomial that we're going to look at. And this right here, a little binomial that we're going to look at. And now what we have to do is we have to find the GCF of each binomial. So what is the GCF of 5x squared plus x? Now, if you have to, you can write each term like this, like we did it before in earlier sections. And 5 is just 5 times x, and this is 1 times x. And you see that x is what they have in common. But what we're hoping is that over time, you're able to just kind of pick that out yourself. Okay? So if you need to, do this. If not, it's going to save you some time. Okay? So I know that they both have an x in common. So I'm going to factor out the x and write it as x. So if I factor the x out of this, I'm left with 5x. If I factor x out of this, I am left with 1. Okay, what do these have in common? Now we look at this binomial, 10x plus 2, and I know that they have a 2 in common. And if I factor out a 2 out of 10x, I'm left with 5x. And if I factor out a 1, or I'm sorry, a 2 from 2, I'm left with a 1. And what happens is these two binomials are the same. And now we rewrite this as 5x plus 1 times whatever's on the outside here, x plus 2. And that is 5x squared plus 11x plus 2 factor. Okay, let's try another one. So we're going to find factors of a times c. 6 times 5. A times c is a is 6, c is 5, so that's 30. So we're looking for factors of 30. Factors of 30 are 1 and 30, 2 and 15, 3 and 5, 3 and 10, and 5 and 6. And they're negative counterparts, but I already know I won't need those. The sum, 31, 17, 13, and 11. This is what I'm looking for. So we rewrite this, 6x squared, but instead of 13x, I'm going to rewrite it as 3x plus 10x plus 5. And I got the 3x and the 10x from this right here. Okay, so now remember, two separate binomials. So 6x squared and 3x, what do they have in common? What's their GCF? Their GCF is 3. They both have a 3 in common and an x. If I take 6x squared divided by 3x, I am left with 2x. If I take 3x and divide it by 3x, I am left with 1. What do 10x and 5 have in common? They both have a 5. 10x divided by 5 is 2x, and 5 divided by 5 is 1. And now as you see, we both factored 2x plus 1. So that's going to be one of our binomials, and this 3x plus 5 is our other one. Okay? All right. And hop forward a little bit and show you, again, if you kind of struggled with those, I would go back and rewatch that first part of the video. Also, if you want a little bit more practice, if you go to the book, page 519, there are a couple of examples that you can try on your own, and they show it kind of worked out for you. Okay. The other thing that we didn't do on the previous ones, because I wanted to kind of just show you how to do this without adding more to your plate, is one thing we should always do is see if anything in here, any of these coefficients have something in common. And so for this one, we can factor out a 3. 18 has a factor of 3, 33 has a factor of 3, and 12 has a factor of 3. And again, that would just be something where you could factor them out and find that, but hopefully over time you just notice it. So if we take a 3 out of there, 18 divided by 3 is 6. 33 divided by 3 is 11, and 12 divided by 3 is 4. Okay? So now, we're going to finish factoring this. And since it's in the form of ax squared minus bx plus c, we know that we want factors of 6 and 4. So factors of 6 times 4 is 24. And this is the sum. Factors of 24, 1 and 24, 2 and 12. What else do we got? We got 3 and 8, 4 and 6, and that should be it. 1 and 24 is 25. 2 and 12 is 14. 3 and 8 is 11. 4 and 6 is 10. We are looking for a negative 11. We don't have that yet. So what we're missing is the negative values. Well, hopefully you're getting better at this, and we'll notice that all we need is negative 3 and negative 8. Right? Negative 3 and negative 8 still give us positive 24, but the sum is negative 11. So there is what we're looking for. And those are our numbers. So we rewrite this. Don't forget this little 3. Okay, we're going to rewrite this as 3 times 6x squared minus 3x minus 8x plus 4. So again, I rewrote this. Instead of negative 11x, I rewrote it as negative 3x minus 8x. Separate these two. Remember, this one and this is separate. What does 6x squared and negative 3x have in common? They both have a 3x. So 3x times what's left here is a 2x minus 1. What does negative 8 and 4 have in common? They both have, so in this case, so that this works out, we're going to have to make this negative 4. And the reason is, if we take a negative 4 out of here, we'd like this leading coefficient to be positive if possible. Negative 8x divided by negative 4 is 2x. Positive 4 divided by negative 4 is negative 1. Notice how these binomials are the same now. So don't forget this 3. 2x minus 1, because that's what they have in common there. And then what's left over? 3x minus 4. And that is how you factor something like that out if they have something in common first. Okay? I know that's a little bit confusing, but write down any questions that you have.